Sample preparation for AAS analysis. Okay, we'll focus on the wet digestion and also dry etching method. It is used for solid sample preparation. Okay, tapi untuk wet digestion ni untuk liquid sample pun boleh. Okay, kenapa kita perlu buat sample preparation? Okay, the sample preparation is used to destroy the interference element, which is the element which is not of our interest, in which this element akan interfere during the atomization process. Okay, how it can be done by wet digestion and also dry etching method. Okay, these two techniques use the decomposition technique, in which your sample matrix will decompose. Okay, the first method is wet digestion by using the microwave, and this method is the best method to convert liquid or solid sample into solution. Macam mana proses ni? By combining acid with your sample under high temperature and pressure inside this microwave, and then the sample holder will use the digestion vessel. Okay, in which it is closely kept lah, dia ditutup kemas lah macam ni, so it is suitable for volatile element. Okay, then this technique also is highly efficient and almost any sample can be digested. Okay, wet digestion ni due to the acid will dissolve your sample into aqueous solution. Contoh kata acid tu adalah HNO3. HNO3, okay, NO3 nitrate ni akan form soluble solution with the metal, and then this soluble solution is what we call is ready to be analyzed by AAS instrument. Dia akan go aspiration, the suck of the liquid sample into the nebulizer chamber, and dia akan berlakulah proses atomization tu. It is suitable lah. So before that, your sample must be undergone sample preparation by wet digestion ataupun dry etch lah. Okay, so untuk wet digestion guna hot plate, it is the same thing. The concept dia, your sample is mixed with acid and apply temperature in the hot plate. Okay, the sample container used for this method is glass or Teflon beakers. And untuk geological sample macam rock atau batu, dia require tough digestion. Dia akan guna this type of acid and will be heated at very high temperature, 1200 degree Celsius, and this sample need to use the container from graphite crucible. Okay, so the problem here is loss of the volatile element due to dia guna dalam, dia hanyalah dipanaskan dan atas hot plate, dan container dia pun ada akan menyebabkan loss of volatile element. So it is not suitable lah kalau kita punya metal of interest is volatile. Okay, untuk dry etching method for analysis of non-volatile element, mainly used for organic sample. Okay, first sample is dried and burned at 500 hingga 600 degree Celsius inside the furnace in order to remove the carbonaceous matter. So it is suitable for solid sample. Letak dalam bekas dia, crucible ni, and heated lah at high temperature. So first thing first, the water and moisture solid dalam sample ni akan liquid dalam sample ni akan being evaporated, and also at high temperature the carbonaceous matter, carbon dalam, contoh kata dalam organic compound, carbon ni akan react dengan oxygen inside the air and being burned and will release the carbon dioxide. So for this method, metric effect are very much reduced. Metric effect ni adalah effect daripada elemen lain yang ada dalam you all punya sample but not the metal of interest. Okay, so for quantitative analysis, we can use the calibration curve method and also the standard addition method. Okay, kita dah belajar dalam UV-Vis spectroscopy hari itu. Okay, so from AAS kita akan dapat sampel kita akan dapat tahu the absorbance of that sample. So macam biasalah melalui graph ni ataupun melalui equation, kita boleh dapat tahu concentration of the analyte, which is what we call as quantitative analysis. Okay, the quantitative analysis follow Beer-Lambert law, and the concentration of unknown are determined by the same way using the formula A equal to epsilon darab B darab C. And in this case, your sample is inside the flame. So the beam path length, kalau dulu dalam UV adalah width of the cuvette, tapi dalam AAS ia adalah width of the flame. Okay, for calibration curve, kita compare, teknik ni adalah compare the unknown to a set of standard of known concentration. Dia akan form a linear plot between absorbent versus the concentration of the analyte lah. Okay, so kita tak boleh guna single standard, dia kena ada a set of standard. Okay, this is the standard calibration curve. Okay, for example, you want to determine the concentration of the ferrum inside your sample. So you must prepare the standard solution in which you dissolve the ferrum. The ferrum which you know the concentration. Okay, ferrum ni yang commercial punya lah, yang you beli commercially. And then your unknown sample ni, contoh kata sample raw water. Okay, so you decide to prepare 2 microgram ferrum, and you examine dia punya, and you test through AAS, and you dapat dia punya absorbance 0.2, and then yang ni 3 microgram of ferrum, absorbance dia, dan 4 microgram, ni pun 7 microgram dan seterusnya, and you know its absorbance, so you can plot the straight graph like this. Okay, sebab apa you boleh plot? Sebab you tahu the concentration, you buat that standard. So untuk standard yang you dapat daripada water, daripada raw water, daripada sampel river, contoh kata you tak tahu dia punya concentration, so you nak tahu dia punya concentration, you buat AAS, in which dekat AAS tu dia akan keluar the absorbance. Contohnya absorbance dia dekat 0.35, and then you pun just, sebab dah ada straight line macam ni, you pun just extrapolate ni, then go down, and then you akan tahu, okay, your sample from the river, unknown sample from the river, dia punya concentration adalah about 3.7 microgram of ferrum. So this is the standard calibration curve. We must use a set of standard with known concentration. Macam mana nak dapatkan standard ferrum ni? Kita boleh dapat beli secara komersial. Okay, untuk standard addition method is used to overcome the metric effect due to the presence of a lot of impurities in the sample. Okay, involved by adding one or more increment of a standard solution to sample aliquots of the same size. Each solution is diluted to a fixed volume before measuring its absorbance. Okay, sama juga, kita kena prepare a set of standard, cuma beza dia kat sini, untuk standard tu kita letak juga sample kita. Dalam tu kita letak juga sample kita. Okay, this is the way. Okay, we have, let's say we have 4 volumetric flask. Kita first thing first, kita masukkan unknown solution kita dulu, yang warna biru ni, the same amount of unknown solution. Contoh kata tadi, dalam calibration curve tadi kita guna water, nak detect ferrum dalam river kan. So kita masukkan dulu yang biru ni, contoh kata adalah sample water from the river, and then stock solution ni adalah ferrum, kita punya commercial ferrum. Okay, so kita akan add different amount of ferrum standard solution inside you punya sample. Okay, for standard addition method, kalau kita guna dua volumetric flask, satu kita letak kita punya unknown sample je, satu lagi barulah kita letak kita punya standard solution. Okay, so ada one increment of sample, we call it as single point standard addition method. Untuk multiple addition ni, yang macam tadilah kita add different amount of standard inside the volumetric flask. Okay, for single point standard addition, untuk diluted sample yang tak ada standard, kita guna formula ni. X ni for unknown. Okay, untuk sample volumetric flask yang ada standard, kita guna this formula. Absorbent untuk sample, unknown sample plus absorbent untuk standard. Okay, so kalau you nak lagi jelas, okay, ni adalah volumetric flask, ni adalah volumetric flask. Untuk single addition method, kita akan add the same amount of the unknown sample dalam ni, and then di kedua ni kita tambah standard solution yang kita nak carilah. Contoh kata ferrum, kita tambahkan ferrum standard solution, and then both kita diluted to the diluted mark lah. Okay. Okay. So these are the equation, and by dividing equation 2 to equation 1, kita akan dapat this equation. So in order to know the concentration of the unknown, we can use this formula. Okay, so you can tengoklah soalan ni sama je. Okay, then another thing ni adalah untuk multiple addition technique method. Untuk multiple addition, this one volume of standard, this one is absorbent. So kita tahu kita tambah standard tu berapa and absorbent tu berapa. So kita boleh plot the graph macam ni. So by using this technique, kita juga boleh guna this formula lah. Zero ni adalah the volume of standard at x-intercept, in which y is 0 lah. Kita ambil kat sini. So kita masukkan dalam equation pun boleh dapat the concentration of the analyte. Okay. Okay, so tadi macam mana kita boleh dapat volume of standard versus absorbent is by using this formula lah. Okay, by using this formula, A ni adalah Y, mx, with standard adalah x plus c. Okay, so that's why kita dapat plot macam ni. So kita just plot lah. Kadang-kadang dalam soalan dia dah bagi plot. Okay, so untuk dapatkan cx, kita kena substitute this formula. Okay, and then this is the final formula. This one, c ni adalah y-intercept. C standard ni you dapatkan daripada petikan. M ni adalah gradient. So kalau macam ni, sini soalan akan bagi y equal to mx plus c. So you kena tahu nak detect yang mana m, mana gradient, and yang mana the y-intercept lah. So that boleh masuk dalam formula ni. Okay, contoh kata kalau dia suruh you lukis graph, dia tak bagi apa, dia tak bagi m ni berapa, dia tak bagi c ni berapa, sebabnya you kena lukis sendiri. So m ni adalah y2 minus y1 divide by x2 minus x1. Okay, you cari slope lah. Okay. Okay, y2 minus y1 x2 minus x1. So you akan dapat the m lah. Untuk c ni pula y-intercept you boleh dapatkan kat sini. Kalau dia tak bagilah, kalau dia bagi just tak payah cari, just guna through this equation. Okay, this one example you boleh tengok sendirilah, dia akan bagi the volume of standard. The volume of the added standard, dia akan bagi absorbent. So you boleh dia akan bagi graph macam ni. Okay, this one adalah M gradient, this one adalah C. Okay, C here. Kalau dia bagi, you tak payah cari. Kalau dia tak bagi, then you kena carilah M ni Y2 minus Y1, Y2 minus Y1, X2 minus X1 lah. Okay, so you just masukkan dalam formula, then you akan dapat berapa amount of the concentration of the analyte. Okay, tadi dekat x-axis dia bagi volume of standard. So sekarang dia dah bagi siap-siap concentration of the added standard and absorbent. So directly, tapi dia tak bagi the volume kan, the volume of the added standard, dia bagi terus concentration. Dia suruh cari the amount of the silicon present in the ore sample. So you can dapatkan directly lah by determining the x-intercept. X-intercept ni bila y is 0. So you cari kat sini, bila y 0, x-intercept dia dekat negatif 7 part per billion. So okay, so you akan dapat 7 part per billion lah. Yang ni kalau dia bagi x-axis dia adalah concentration of standard, you can directly get the concentration lah. Kalau macam yang contoh 1 tadi, kat sini volume of standard. Okay, so detection limits and accuracy. Okay, detection limit ni adalah the lowest concentration that can be measured using that instrument. Okay, untuk for example, calcium, cadmium, chromium and copper from 1 to 5 ppb to more than 1000 ppb. Tapi some element cannot be measured at all using this AAS spectroscopy. So accuracy dia high sensitivity for most element, and then the high accuracy at the concentration at the ppm level.